Hi guys, I got a fun tutorial for you today. I'm going to be making a few over the next few weeks, this being the first one. It's my 15-year anniversary on YouTube. I can't believe it's been that long. 15 years on YouTube. It's scary. So this is what we're going to make. I've been seeing a lot of these type of effects where like they fill an object with a bunch of whatever instances. And I thought that I thought I could one up them. So that's pretty much why I made this. I've done a few other tutorials, or not tutorials, but I've done a few other effects that were similar to this in the past. Like this one here. And these, it's not exactly the same thing. I actually booleaned these objects and use parts and instances for this. And this one as well. But the concept very similar. They're just slight variations. But like I said, these are done with actually booleaning the geometry and parts and instances. Whereas the one I'm doing now is totally done with textures. And there's some advantages to that and disadvantages, but I think it's really cool that like this type of thing is even possible in Lightwave. And there's like a ton of cool effects you could do with doing it with textures, and it's more elegant in my opinion. So that's why I'm going to show. I may at some point show how to do it with Boolean geometry, but I think the texture version is better for tutorial. So that's why I'm going to do it that way. And the only other thing I want to say is that if any of you use any of these tools at all, please go donate to Dennis. And because none of this stuff would be possible without his tools, and he is continually updating them, as he just updates them continually. So, I mean, if you use any of his tools at all, please go donate to him and download all of his tools and use them because they're all really, really good. I know he's updated a few in the past couple weeks with DP Boolean and right intersect and a couple other nodes and it's just, his tools are really great. So if you want to give me anything for my 15-year YouTube anniversary, go donate to Dennis. So that's pretty much it. But this is what we're going to create in this tutorial here, and it's animated. And it's basically just this voxelized build-up effect, but you could do it with any kind of closed geometry and it'll work. So let's just get started. I'm not going to go through the modeling for this one because they're all basic objects and it's not really the focus of this tutorial, but I'll go through all the objects so you can see exactly what they are and how this all comes together. So the first layer is just this logo, BP logo, and I've remeshed it in ZBrush. I made it in Lightwave and remeshed it in ZBrush. Then the second layer is just this truncated octahedron, and it's 1 meter grid size. So it's set to be cloned at 1 meter, and I'm just doing that because it'll make the nodes much easier. It'll just make the setup much easier if everything's just one unit. And for the next layer, it's just this box here, and this is just going to be the bounds for our array of truncated octahedrons. It's just a way for us to visualize where they're going to be in 3D space. And then the next layer here is these curves, and it's just curves there's 7 curves. They all start from the center, and they go around like this. And then what I did is I took a 1-point poly and then extruded those 1-point poly along those curves so that we got this. And then I also created UVs when I extruded it so that you can see I have a UV map that goes from the center to the end. And that's what we use to pretty much grow this out, is that UV map. And then on the last layer here, all it is just a plane that we're going to use to visualize these this 2-point poly animation. So that's pretty much all there is to it. Let's just get started. So the first thing we want to do is load the BP, the cell, and the bounds for the cell. So I'm just going to load all three of those layers. And then I'm just going to fix the grid size, move the BP out of the way. So the first part of this is just creating the array. And I'm just turning off so none of that renders. And I'm turning the bounds on wireframe. So the first thing we're going to do is we're going to load nodal motion onto the bounds object. And what we're going to do is we're just going to quantize the position and scale of this bounds so that it's always on 1 meter. So I'm going to get a dpkit item info and it's set to self. So we're getting the bounds. And I'm going to get a TrueArt Tools quantize vector. And I'm going to get an AS Tools, or I'm going to get a constant scalar. And I'm going to get an AS Tools Tools Logic or Math clamp. This is a vector clamp. And I'm going to clone the quantize. So we're going to quantize the position and the scale. The position, we can go right into the position. But for the scale, what I want to do is I want to clamp it at 1, so it can't go below 1. And then I'll just put the max at like 200 or something. And then the scalar is just set to 1. And like I said, everything is at 1 meter here just because it keeps the nodes as simple as possible. So now you can see if we move and scale this, it's all set up for, it's all quantized by 1 meter. So I'm just creating a little bit of a box here. Now what we're going to do is we're just going to instance this octahedron in an array. But we got to do that with nodes because there's no built-in tool for that. So I'm just going to add. I added the instancer to the octahedron. Now I'm just adding the octahedron to it. Put it on grouped pivot. And I'm just turning it on shaded solid, making it 5,000 max instances for now. Going to the nodal. And now we're just going to create a 3D array of these. It'll be like a honeycomb basically. So we're just going to get a dpkit instance info and add. We're going to add -1 so we can start at 0. And we're going to get math or a dpkit item info. We're going to get a split vector. And we're going to get a make vector. So now we're going to get a let's see, mod. And we're just going to mod that index by the X. And we're going to select our object, the bounds. And you can see that'll give us, it'll just modding it by whatever the X scale was. Now to get the Z, what we're going to do is we're going to divide by the X. We're going to divide the index by the X. Then we're going to floor that. And then we're going to mod that by the Z. And that'll give us the Z scale. So that's that. And now the Y is a little bit more complex because they're offset a little bit, but we'll get to that. So to get the Y, what we do is we multiply the X times the Z. Then we divide that and floor it. Now I messed up there. That should have went into the bottom input. I'll fix it in a second. So it's messed up because I have them inputs on the divide switched. So I just switched them. Now it'll be right. So that does that. But now you'll see it's not a meter. We actually only want it to be a half meter in between them because that's the way honeycomb works. So we're just going to multiply that by 0.5. And that'll give us that. But now we have to move them on the X and the Z as well. So what we can do is we get a mod, another mod. And we'll mod that by 2, the floored amount. And that'll just, for each layer, it'll count to 0 and 1 over and over again. So I'm just going to get a vector add 4. And AS Tools, Logic, Vector. So we're just going to take the mod into A. And I'm going to create a vector. So if it's not equal to 0, then I want to just move them on the X and the Y by 0.5. So now you can see now it puts it in a proper honeycomb. So now we got to clip it so that we're not drawing all the ones that go on the top. So basically what we want to do here is multiply the X times the Z times Y times 2. So I'll multiply the Y times 2, and then we're multiplying that by the X and the Z. The reason you have to multiply the Y times 2 is because of the way we had to scale them down, because of how there's only half a meter in between. Now I messed up there because I'm only scaling it by 0.2. That's why you can see it's broken. So we're just taking the X times the Y times 2 times Z. And we're saying if that amount is greater than the index, then we'll have it equal 1. And if not, we'll have it equal 0. See, now I'm realizing that I didn't have to multiply by 0.2. So now it works out. It was just that multiply had 0.2 instead of 2. And we're just clipping all the ones that are greater than X times Y times 2 times Z. So now you can see when we scale the array, but when we move it, nothing happens, and that's because I never hooked up the position. So we just got to take the position from our bounds and add it into the position for our instances. So now we can move and scale this however we want it. So now I'm just bringing that BP back over. I'm going to put it on wireframe. Then I'm just going to scale and move the bounds just so that it completely fills up this. So I'm just scaling and moving this just to get it to so that we can cover the whole logo with these instances. If you just want to see a more advanced way to set up a grid like this, if you watch the Plexus Part 2, it shows a more advanced way to set this up so you can change the resolution. But just to keep it simple for this, that's why I just left everything at 1, because it keeps the nodes way easier. So that's pretty much it. Now I just got to scale it on the Y. And then the reason the instances aren't there is because there's not enough. So I'll just put the max instances up to 75,000. So now, but what we don't really want to render all of them. So we want to get rid of as many as we don't need. So the way we can do this is we can use a Boolean node. So if I get dpkit shaders Boolean, and we're going to select the BP logo. and we're going to get a replace spot, and we're going to replace the spot with our instance position there, and the alpha for the Boolean node goes into the alpha for the replace spot. Select BP, put it on inside, and now you can see it cuts out the instances where the logo is. Now you can see that little straggler there, and it's easy to fix. It's just a floating point error. I rarely get them actually ever with this node, but happen to get one here. So all you got to do is just add 0.0001 on the Z, and that'll fix it completely, and it won't affect anything else. Like, you could still animate with it, and it's not going to have any effect. So you just add that in there. So now, but what we need is, we can't have any of that black mesh showing through like it is. We need actually another layer of these for the effect that we're doing. So what I'm going to do is I'm going to get a tools blur, dpkit tools blur, and I'm going to get a math scalar seal. And what I'm going to do is I'm just going to blur that Boolean, and then I'm going to seal that. So it would be kind of like you do a blur in Photoshop and then use levels on it so that you can control where the border is. That's basically the same idea. You'll see. So I'm going to blur it by 500 millimeters on the X, Y, and Z with 2x2. Now, this, I have it on 2x2 because this doesn't have to be calculated over and over, and you can see once. So it's just going to blur it and then select all the values that are above 0, basically. So now I just turned off the refresh because we don't, that's all we need to do with these instances. They don't need to refresh, they're not going to be animated or anything like that. So now what I'm doing is I'm selecting the instancer, and I'm selecting this plugin. It's called Type 2 Instance to Points, and it just creates an object with points that are the instances, where the instances are. So you can see that's right there. So you just select the mesh and run that plugin, and it creates a mesh with the points where the instances are. And that's important for our surfacing. And I'm just saving that object as tessellation points. So it's saved now as well. So that's pretty much it. So I'm going to save the scene and the object, and then start on the next part. So for the next part of this, we're just going to load those poly lines with the weight map and the test plane into another scene here. And fix the grid size. I didn't even fix it. But we're going to go into the surface for the test plane, test screen. And it's easier to visualize how this is working if we do it like this, and then I load it into the other object. So I'm just going to get a dpkit item info nearest point, and I'm going to get a dpkit item info point info. And we want to select our poly lines for both of those and put the index into the index. And to start out with, we'll get a functions wrap, and I'm just going to take the U. I'm going to select our UV map. It's called growth fall off, and I'm going to take the U into the input of our wrap. And so if I get a scalar logic, and if I get the distance here, and I get our UV map, and if I just say if A is less than B, you'll see what that gives us. So you can see what it gives us. I'm just turning VPR so it's draft mode off. Now I'm turning it so that the lines don't render, because right now we're rendering those 2-point polys, and we don't need to. So this is what it gives us. So what I'm going to do is I'm going to get a IFW2 waveform bias, and you can use the native one. I'm just using this one because the inverts. The invert is built into it. That's an option. So I'm just going into the function with that bias, and I want to turn the revert or invert on. So now you can see it just flipped the UV base, the U, Now I want it to be 300 amplitude and upper clip at 300 as well. So that gives us that. And I want the bias to be on 70 or 75. So that gives us that. So, and keep in mind, this is a 3D texture as well. It's just we're visualizing it in 2D. So just keep that in mind. So now what we want to do here is we need to animate this. So we're going to get a scalar add. And if we go in from our wrap into the add, and we go into our logic. So if we just animate this add here from like, I think it's like -2 or something, -3, and over 300 frames, because that's about how long I want this to take. It'll be a little shorter than that probably. So at frame 300, I want the value to be +2, and that's not high enough. But you'll see what it's doing. So that's pretty much how we're going to reveal this tessellation. So now I'm just changing the value up to 4 because it needs to encompass the whole. It needs to encompass the whole BP plus even a little more because those instances are a little bit bigger even. So now I'm just inverting it so that it's black in the middle, because for a clip map that's what you want it to use. So one thing I'm doing here is I'm going to get a, I think that's a max, and I want to clip it so that at 0.5 so that it's not going to draw anything that's closer than 0.5 basically. So that's all that's doing, and the reason for that is because I don't want that little thing. It's just, it works better this way. I found it looks better when it animates, because sometimes that little thing will go, because we're going to add a deformation to this too. So you can see I just got a turbulence, and I'm going to turn it on 20 meters. And we're going to get another add, and we're just going to add that turbulence in there. So if we turn the opacity up, you can see what it's doing. I'm going to turn it down to 10 meters. So that gives us that. But you can see now it kind of breaks up in the beginning, which I don't like that. So what I'm going to do is I'm just going to animate that value so that in the beginning it's at 0. That's the alpha for the turbulence. And at frame 300 I want to be at 300%. And I'm also going to turn the bias on that up. So now you'll see that keeps them pretty much all together, so it's not breaking up like that. A little bit I don't mind at the end, but I just didn't want it breaking up real in the beginning like that. So that's pretty much all we're going to use for the to reveal this. Now I'm just adjusting the timing because it didn't show up till a little bit late. So that's pretty much is. I also do want to add, I added displacement map to these points, which you'll see in a second. So that's pretty much all there is for that. Now what I do is I just add a deformation map to these 2-point polylines. Just go into the nodes. I'm going to get R-Man collection, 3D textures, Garber noise. And I'm going to take the bump into the deformation. And we'll put them at 30 meters. And I'm going to turn the bump up pretty high, like 7,000. And you can see that gives us that. So that's pretty much all there is for that part. Now we just got to import that into our other scene and we can animate this. So I'm just going to save this as a growth texture, I believe I call it, yeah. So for the next part of this, we're going to load these poly lines into that original scene we had. So I'm just going to load that original scene. It's called tessellation. And first thing I'm going to do is just fix some of these settings so it's easy to work with. I'm going to go into our instancer, and we don't need to view these at all. So I just want to turn preview to none. And I'm going to go into the camera, just making sure render lines isn't selected so we don't have to deal with that. Fixing these AA settings a little bit. And I'm just turning those points off so we can't see them, because they don't need to be seen. And now we can load that. We're going to load items from scene, from growth texture, and we just need the poly lines. And you can see it loaded them. I'm going to change the color. We don't have to render them at all, so I turned it so they don't render. Made them red. Now I am going to turn up the deformations in that, because now I can see them inside the actual logo. So I'm just turning up to 10,000. That's more of what I was going for. So that's all there is for that. Now we're going to copy those nodes that we created from the test screen, and we're just going to paste nodes into the cell. And we don't need it in the color, but what we're going to do here is we're going to get a DP kit instance info, and we're going to get a DP filter, tools, replace spot. And what we're going to do is we're going to, that texture that we made in the other scene, we're going to replace the spot with the instance position, world spot. And you'll be able to see now that it'll we got to turn our B off for now. So you can see now it's only going to show the instances where that. Now keep in mind, this can also be done with procedural textures. It doesn't have to be the texture we made. Now I'm putting that texture on world coordinates. That's important, because if it's not, it won't work properly. You got to make sure that that turbulence texture that we created is in world coordinates. And now it'll work exactly as it's supposed to. But you could use another boolean, DP boolean, you can use pretty much any 3D texture to do this with. I'm just using that one we created. Now I'm adjusting that. It's just the timing on how they come out. Same thing we were doing in that last scene. It needs to get bigger. So that's pretty much, we're good with that. Now I'm going to save the scene, call this Voxelate. So what we want to do now is we want to cut the B out of that as well. So if we get a DP kit, shaders, boolean, and we're going to select the logo, put it on outside. Now if we math, scalar add, we add these together, and then we want to, we're going to get a math, we're going to get a min here, and we're going to set it to 1. It's probably not necessary, but I'd just like to keep it in range from 0 to 1. And we'll go into the clip map. So you'll be able to see now that it cuts out, the B gets cut out as well. So you're not seeing those extra instances anymore. You're just seeing what's inside the logo, basically. So So now I'm going to turn the B on because now we got to deal with revealing that, and it's pretty much the same thing. So, but we're just going to copy those nodes out. So pretty much we don't need the instance info, but everything but that. It's the same thing that was in the test screen. Plus that replace spot node. So what we're going to do here is to get this to work. I'm going to show you what it looks like now without just turning these instances off, so you don't have to view them, and you can see what that does if I just take it in. So that's the effect it gets. But that's not really what we need. It's close, but we need it to be based on the those points, the ones that we created from the instances. So if we get a dpkit item info nearest point, and we get tessellation points, and we use that in the world spot there, and then we go into the alpha or the clip map, now you'll see it'll give us exactly what we need. And the reason this works is because that's happens to be with a cube grid, an even cube grid, and an even honeycomb grid. A Voronoi pattern will exactly match up. So you could do this with either a cube or a honeycomb pattern. It'll work for either. So now I'm going to turn the instances back on, and you can see what we get. And I mean, it's just real nice that you're able to do that. It works, like I said, it will work with a honeycomb or a cube grid. So now what I'm doing here is I'm just adding a texture because I do got to make a thumbnail for this video. So I'm going to texture a little bit. So I'm adding a backdrop, just an HDR backdrop, using a black background, and I'm turning off our light so it doesn't render. I'm going to go into the camera properties, turn on global illumination, important sampling, 4 samples. All that looks pretty good. And I'm turning the ambient intensity down. So you can see that'll give us that. It's just, it gives you a little better idea of what the contour looks like when you use GI. So I'm going to texture this a little bit. Like I said, it's not really a texturing tutorial, but I do want to show you one kind of thing we can do with this. So for the B, I'm just going to, it's nothing fancy. I'm just going to get a conductor here. I'm going to put in the material. Make the specular 75 and the roughness 20. And I want to put the color at 90. It's the grayscale 90. And reflection blur on. And I'm just going to copy that. I'm going to go into the cell. Now for the cell, we're going to do a little bit here because I want to make this a little bit interesting. So what we're going to do is the reason this works as well as it does is because the points are nice and evenly spaced on that control grid, or on the BP logo. So I'm just going to get the nearest point of the BP logo, and I'm going to plug the instance position into that. So we're just getting the distance to the nearest point on the BP logo from the instance, and I'm going to plug that into a gradient. I'm going to set these keys to linear, and I'm going to put the first one at 90, which matches the that other surface we just did. I'm going to put the second one at a little bit less, probably like 6 or 7. And then the third one I'm going to make some other brighter color. So what this is going to give the effect of is it's going to color them based on how far from the surface it is. So as you get deeper into the B, the logo, it's going to the color it'll ramp to orange basically. You'll see right here. So you can see on the outside it's the same gray color, and then as you get deeper inside, it goes to dark, and then it goes to that orange color. And like I said, there's a billion different ways you could use that weight map to surface this and kind of have like a fading effect. There's a ton of different things you can do with the surfacing. Right now I'm just cranking this global illumination up temporarily just so I can get a better view of this. So, I mean, I'm pretty happy with it. I'm not going to go too crazy with the surfacing, but there's a ton of different things you can do with the surfacing. I am going to add a couple more things just because, like I said, I want to make a thumbnail with it at least. So it needs to look that good, at least that good. So I'm just getting a DP Kit edge node. And what I'm going to do is just going to take the gradient into the background color for the edge. Going to make the width 0.5 and then the fuzzy at 1.5. I think this kind of accentuates the octahedrons a little bit. Now I think I forgot to plug it in here. Pretty sure I did, yeah. So I'm plugging that in. I'm going to go on the VPR. And it's doing what I want, but it's not as drastic as I want it. So I'm going to turn it up to 0.5. I'm just messing with the settings here. I probably could have left all this out, but I wanted to just show you a little bit with the surfacing, just so you have an idea of the kind of thing you could do. So right now I'm just going to turn the specularity to 50, turn the roughness to 10, and I'm going to turn that color up a little bit so I don't have to turn the GI up so high to 120. And then I'm just going to do the same thing in that other node. 50, 10 on the blurry, and then for the gradient we want that to be at 120. And I turn that middle key up a little bit too. I think that's pretty much all I do for the surfacing. I turn the GI back down to 100. That's giving me more of what I was going for. I'm going to do something more elaborate. I'm going to do a couple animations with the logo, but I'm not gonna make it. It's too complex for a tutorial to. It'd take too long. But this is good enough to give you an idea of stuff you could do. Still adjusting this edge. I turned it down to 0.3. I think I'll leave it at that. I might mess with it again. Maybe I go to 0.2. So that's pretty much it. I think I just set it up here for a quick render. One thing I would do is if you're setting this up for an animation, I take them samples down to 2. For 2015 anyway, I put it on classic motion blur, and I put the motion blur passes on 8. And what that will do is that will cause it'll kind of fade in a little bit, and it won't be too noticeable, but it kind of, instead of them popping in, it'll fade in. You could also do this instead of, like I did this with a clip map, but you could also do this with transparency and fade them on, but I didn't want to get into that, but because I think this is just as good of an effect. So that's pretty much it. I did put the thumbnail composition files in the in the files that I'm going to put in the description. So you'll be able to see the composition files. I used OpenImage denoise and a DP filter just to do a little quick composition with the logo, so I could put it on the thumbnail for YouTube. But that's pretty much it. I thought it was cool. I thought it was cool that it was even possible to do something like this in Lightwave. But hope you guys enjoyed it. Take care.